Okay, thank you very much. Xenia, may I begin?
Well, I think yes, so maybe we can wait for a couple of minutes, maybe a few more participants will join.
Okay, let me see. Maybe I will leave my slides like this. Or do I have animations? I don't think I have animations, because then if I put my whole screen, I don't see you. But let me see what I can do. Oh, I guess I see you, but I don't see all the slides. Okay. Let's start in 1 minute. Okay, I will begin. And if somebody rolls in, that is totally fine. Please feel free to ask me questions along the way, but we will also have time at the end. My name is Mari Arsalidu, and I'm going to talk about eye tracking in education, business, as well as research. So research that we do in cognitive science, developmental cognitive science in my lab. And this is within the context of, this presentation is within the context of the Science of Learning and Assessment program. This is one of the kinds of research we do. And eye tracking is a very interesting tool that we use to collect data. So it's another way of assessing things. So what is eye tracking? Eye tracking is a technique, it's a method that we use to record eye movements. So where the eye is looking, where the eye has moved, how fast it's moving, where it is fixated, and if your eye blinks, the eye tracker records all that information. So why is it important? Why do we care about eye movements? If your eyes are open, the place that you're looking at is most likely the place here that you're paying attention. It's not always true, but most of the time it is true. So if your eye movements tell us that you're paying attention somewhere, it means that we know what you're processing, what you're thinking about. Okay, so and attention is very valuable. It's very valuable. I mean, in some good ways and in some bad ways. Everybody is trying to catch our attention, right? So if we are looking in a classroom, children who pay attention, it means they're following what the teacher is saying, are the ones that are more likely to do better in their learning. If you are in marketplace, at the store, for example, where you're looking is maybe how you're going to make decisions about your purchasing decisions. Okay, so it is valuable in many things, and we're going to cover some of that. Alfred Yarbus was a Russian scientist. He was not the first one to study eye movements, but he was one of the first to make it much more popular. And he was one of the first to devise one of these devices he made up for studying eye movements back in the day. And there were some other ones where they actually open up the eye of the person and put coils in them. They look a little bit more intense. But here they had cameras, and they were recording how the eye was moving when they looked at different things. And his work has been famous in terms of the history of eye tracking, of eye movements. Okay, so this is one of the first experiments he did. He showed participants this painting by Leah Lepin. Okay, so imagine now you're looking at this painting. You can look around the image randomly, but what if I tell you how old are the participants in the picture? So then you need to look at somewhere else. So if I ask you now, for example, how well off, like what's the socioeconomic status of this family? Are they poor? Are they rich? So where would you be looking at now? Like you're probably looking maybe that they have a piano, that they have paintings on the wall, they have chairs, they have different people opening doors, maybe they have help. All right, so now what if I tell you how long was this person away? How can you estimate? Where would you be looking for that, right? So the first moment when I asked, I just showed you the picture, you were looking at the image, at your own, you're searching around the image by yourselves. Then when I asked about the age of the participant, you were likely looking more at the faces, the children, the older woman, the visitor. And when I asked you about how well off the participants, the family here is, you would say you are looking around for objects, right? Okay, this is basically what Yarbus did. He showed the picture and recorded the eye movements. This was free examination. So if you imagine this image superimposed on the painting, you would see that the people were looking here, and 1, 2, 3 here, and some parts here. And then if you look at the ages of the people, look how much more they look at the faces of each one. Estimate material circumstances of the family. You look more scattered around. Estimate how long the visitor had been away. You look much more at the faces, right? You look to see how is the old lady looking at the visitor? How are the children looking at the visitor? Like there's so much back and forth to understand the social circumstances there. So we see that eye movements can also be top down rather than only bottom up. What do I mean bottom up? Bottom up is when you see the picture and you just look at it. When I ask you a question about it, it means you have a goal of what you're looking for. And when you have a goal to do something, it means that you have an executive mission to try to achieve, and that is top down. Okay, that's what we mean with bottom up and top down. And that is one very classic set of results from Yarbus' book. And now we have much more interesting and easy to work with eye trackers. The eye tracker is what you see here in front of the screen. the person is doing whatever they need to be doing. We can hear they're playing chess, they might be reading, they might be doing whatever you can show on the screen. And the eye tracker is calibrated to track usually just one eye, but then like the dominant eye, so that we can see where the eye is moving or looking more like millisecond by millisecond. Okay, very, very short time period. So this is a desktop eye tracker. So you can set it up in a laboratory, you can set it up in a school, you can set it up in a clinic, and you have it there. It's not easy to move because it is a desktop, so it is a big tower. This one is an eye tracker we have at the Neurobiological Foundations of Cognitive Development Lab, and it is a laptop. So it's very, very portable. So we have the laptop that we use to calibrate the eye tracker, while anybody can be looking at the screen and playing a game, reading, doing decision making, and so on. So this is a very high precision machine that can follow the eye. We can get many eye movement indicators that we can analyze. I'm going to talk about those metrics in a moment, but this is really cool. This is really cool that we can move it. So we have used actually our eye tracker in different schools. So we take it, we use it in the lab, but we can also take it to the school, put it in the classroom, and we have participants, children, adults, play different games on the portable eye trackers. And now here is some more cool stuff. We have wearable eye trackers, and this is very awesome. Technology is improving very rapidly, and you get this more the picture here with a green background. You see that it looks like an interesting camera and so on. But then you have these nice slick glasses that you can wear outside. And of course, usually the precision and the resolution of the data we get is not as crisp and sharp and precise with movable eye trackers, but it is amazing that we can do more ecologically valid experiments without having to sit in front of a computer, and you can walk around and collect data about eye movements. And this is what has been really interesting in what we see in industry research. In research that we do for scientific research, we usually are really interested to get really good definition data, okay? But in industry, you want to have more practical applications. So both ways are good. It's just these different interests. So what are some of the metrics that we can get? We can get fixations. Fixations are these circles, okay? And we can get the fixation location. We can get the fixation time, how long you are looking at something. So you can look at something very briefly and then move to the next part, or you can look at it, like stare at it for a longer time, okay? So this would be a fixation. So 1, 2, 3, if you can see my mouse, is fixation points. But you also see how big the circle is. It's a way to illustrate the time of its fixation. And we can calculate the time taken looking at a spot, like we predefine on the screen. For example, we say we want to see how much time you, on average, you fixate when you're reading. And then we will add this and make an average, okay? the line between two fixations, what connects two fixations, is called the saccade. Okay, a saccade is the movement you make from point 1 to point B between fixations. And we can also have other metrics. We can measure blink rate, how fast you blink. Technically, the hypothesis is that the more you blink, the more difficult the task is. It's as if you're trying to take in everything and process it. There's also other ones that are called the motion, like they take the path of your search, like you can follow that, and in the following slides I'm going to show you some more. But looking at this example, you see a really nice example about a regression in the reading. So when the person was looking from left to right, they did a little bit of a regression here between the knight attacked the windmill on his donkey, and there was a little bit of regression here between windmill and attacked, and then jump ahead, and so on. And you can see, for example, this would be a very interesting example of children learning how to read, children that have normal reading skills, and children that may have dyslexia, and or children who are younger and children who are older. The speed with which we read as children get older increases, and they can do many more things. So this is an example of research that can be done with education or academic content. I took this heat map from Wikipedia. This is just to show you another way that eye tracking can be used. The heat map indicates that, like, the more red is where more fixations, where more time was spent on the screen for that spot. Okay, and this is of course very important for marketing or usability research. This is how much time they see. You can record how much time participants are looking at different spots on the screen, so that you can put content or rearrange content that is more relevant for you, or more relevant for the users, to decide how you will organize and sell better products or content, and so on. So research, there's many companies that advertise their services of using eye tracking to help with basic things in advertising and marketing and product placements and so on. So even if you go to the store, you will realize that when you have things at eye level, they are more likely to be purchased. And that's why when you go to the store at the lower level, where children are at the eye level, you get some candy and things that are not very good for them, but it's very enticing, because when they walk next to you and they're at the lower eye level, they can get all the sweets. So let's do a few more things. Oh, here there is a ton of research out there on eye tracking, and I wanted to summarize some reviews for you. These are reviews. These are not single one-by-one studies. So, for example, the study in tourism I have here, I can share the links with you at the end. For this study, they looked at 70 eye tracking studies. This is how they advertise places and material. They say, should we use more people in our pictures, or should we use pretty scenery? What attracts more attention? And how do we measure more attention? Is by where and how long participants are looking at things, right? We have a lot of research in marketing. Older reviews were not as very good in being systematic in reporting, but more recent reviews are much more systematic in reporting their methods and the materials. And so I would mostly go for more recent reviews because they're more clear. And advertising as well. So, and in most cases, you will see that they say, yes, eye tracking has these advantages, but also some disadvantages, like every method. In education, eye tracking has been used to discuss things like what are the strategies of students when they're solving physics education, for example, or when they're doing math. In our research, for example, we found that when we're looking at the literature, is that when you offer options in answering mathematical questions to participants, the ones that perform better are those that actually try to solve the answer, but the ones who don't are those who are trying to guess. So if we see them looking at the options, we understand that they're more likely to make a mistake than if they are actually solving the question by looking at the equation rather than the possible solutions. Another very interesting use of eye tracking in education that is very relatively more complex, much more complex to study, is classroom interaction. So it's not just you or the participant on a screen when they're looking at something and they record one-on-one. They are recording interaction between people and between the teachers. So this review has only 6 studies, but it's still very, very interesting. There's also some research where it's not a review, where they researchers have did one-on-one learning, where you have a teacher and a child and a screen, and you are tracking eye movements of both the teacher and the child on how to do this. So we gain a lot of information from eye tracking. We have, I haven't mentioned infancy studies. Infancy studies is when you study infants and toddlers before they can have full language available to them and explain themselves, to see what kind of things they're looking at and how they can decide by how they are looking at their environment. And there's a lot of studies there. There is much less studies in school-age children, maybe because you can talk to those kids and they will tell you what they think. But that is slowly increasing. So we have eye tracking in marketing, eye tracking in gaming, in virtual environments, eye tracking in clinical practice. This is also an interesting area because we do research to see differences between children or adults who have a neurodevelopmental disorder. For example, we know there is a lot of research with children with autism spectrum disorders, where they're studying faces. Children who have autism are not interested in faces, so they will not look on faces like we did, or like we did for the painting of the unexpected visitor. So then we can compare and try to understand why I use eye tracking to understand things like why this is happening, where is the attention going, and so on. So usability research is how products become more user-friendly, so a decision making. And I put I could put many more topics here that researchers and industry has used eye tracking for. They have used eye tracking, for example, in driving experiments to see attention while driving and truck drivers and all these interesting things. And that's why I put a question mark here, that you can add your topic or your interest here. And now I'm going to tell you a little bit. I see some people are chatting there, but I will. I will go over my slides, and then I will go over your questions if that's okay, because I don't have many more slides to show you. Okay, I'm just going to show you some research that I have done with eye tracking, and these are cognitive tasks. And we use the portable eye tracker that I showed at the beginning, which is on a laptop, very easy to set up. We invited participants to play games that have multiple levels of difficulty. They're very child-friendly because we designed this to work with children as well. But these studies I'm showing will be with adults, okay? So adults played games with these color games. Some of them were easy, some of them much more difficult. We had 6 levels. So this is the work of Valentina Bachurina, who was a PhD student with me, did beautiful work with eye tracking. And this first study looked at saccades, how fast saccades were being made, and blink rate. Okay, remember I mentioned that blink rate was related to difficulty. So all the what the participants in our study looked at all those images, and all those images were presented for the same amount of time. But what changed was the difficulty. Like they had more things to process. So here are some cool data that we see. So you see it here, we have 6 levels. Well, every task has 6 levels, but one of them is 1 less and one of them is 1 more. So it looks like it's more, but it's basically you have 6 circles, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And we see this is just the percent of correct trials. So we see that our participants were not making as many correct for the difficult levels, but they did pretty good for the easier levels, okay? So, and the cool thing is that we see this beautiful linear trend, okay? So this is important because we want to relate eye movements with behavior, okay? So because we're studying eye movements, it doesn't mean that we ignore other metrics. And in research, we want to use multiple methods to study the same thing if we can, so that we can look at it from different ways. So this is reaction time. And this is, again, really beautiful to see. We have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 for the blue line and for the orange line, okay? For the, well, I guess it's kind of greenish blue. So then you see how as difficulty increases, reaction time increases, and in a very nice and stable way, which is what we expected to see and how it fits with other data we have on this task. What was really new that we didn't know before is that we use eye tracking this time, and we see that the number of blinks per second decreased with difficulty. So we actually found the opposite thing that was expected before. We actually think that our participants decrease their blink time to try to keep their eyes open to get more difficult things done. And the average peak saccade velocity also decreased. So that means that the type of attention we were showing here is, the velocity decreased, yeah. So they became faster in their movement, in moving around, keep their eyes open and try to solve as much as possible. And this is maybe because our task is more cognitive and it is not perceptual. So it means that it is cognitively demanding. Okay, that's why we call it attentional demand. Okay. And to show you that it is consistent, we actually asked participants how much effort they put in the task, because you can be doing a difficult task but not be interested in not doing it with enough effort. All right. So we said we will not just assume by the person's performance, we will ask them. Okay. So we said, how much effort did you do to play this part of the game that was easy or this part of the game that was hard? And the result was like almost one-on-one. This correlation, I think, was like 96. Like it was so so close. And the same goes here in the two conditions that we have of a mental attentional effort and mental attentional demand. They were very, very, very close. So when we do correlate a blink rate and pixicate velocity with mental effort, we see again that these relations are present for both tasks. Okay, so one more study with eye tracking for you. Now we add one more method. We are using machine learning to predict performance. So we had the data with the balloons and the clowns and the many colors and the many difficulty levels. And we said, can we predict whether a person will make a correct response or incorrect response based on accuracy? Sorry, we wanted to predict accuracy. We had a difficulty level, the reaction time, and eye movements. So this is a pipeline. We used the data, we did all sorts of feature extractions to make sure that our data set was clean, and then we had our features, which are basically the variables we considered in the machine learning process. I think we have like 24 or something. There's a lot of variables we can include. We had things like the standard deviation of reaction time. We had pupil size. We had amplitude of saccades, how long the total time was for fixation, and so on. And then we ran a set of machine learning models to see which one was better. Okay. And the models were more or less very comparable, but I remember we picked one that was the best. Everything is in the paper. And then we chose the best one based on the effect size of the scores. Okay. So this is like a standard pipeline for the analysis. But the cool thing, well, technically, when we use all the data we have with all the parameters, the reaction time, the standard deviation of the manual reaction time was the best, the most important indicator of the analysis. And eye tracking was actually on its own, if we consider eye tracking, was not the most important predictor. Okay, but when we looked at eye tracking on its own, we could order the importance scores. So which parameters of eye tracking are more important when we make prediction about accuracy. And for all tasks, or when we combine the tasks, the mean time of fixation across the total of the trial was the best predictor for eye tracking metrics. Okay, so this in a way means that when you are, how long you're looking in the picture predicts your performance. And the standard deviation of the current saccade duration. So it was the second one, and so on. So this can be target variable. So this is important because not only we can say, yes, we can predict performance in very demanding cognitive tasks with different levels. We not only can predict the performance, but we can provide and give you these important scores so that we can, maybe in subsequent research, pay more attention to the variables that are more likely to be predictive. So next time, maybe I'm not going to be analyzing 20 eye tracking metrics, but I'm just going to be analyzing the top 5 to, let's say, have a more targeted approach in my study in applications. And I understand that some of you might be here because they're interested in eye tracking studies, and we can I would be glad to discuss your ideas or your interests or your questions. If you have interest in doing so, you can look at some best practices in eye tracking research. This is relatively a recent paper, and you can look into more and more people at the HSC are doing studies with eye tracking, and you can look into our master's program on science of learning and assessment to see the types of research we do here, and eye tracking is one of them. So here I will escape my big thing so that I can see you better. And I will be happy to answer your questions. I see here, Alexander, the first. Okay. Second one. Hello, thank you a lot for the interesting topic. Could you please advise studies on eye tracking where level of nervousness, anxiety, fatigue, or other processes of decision making are measured? Elena, that's a very interesting topic. Eye tracking and emotion has been certainly studied. I can't give you one right on the top of my head right now, but if you even go on Google Scholar and look for eye tracking, and if you're interested in clinical disorders or just ratings of nervousness and anxiety and fatigue, those are studies that are probably going to be different, because I'm aware that there are studies with eye tracking and fatigue, because they are very useful in some industries like airline pilots, truck drivers, and so on. So there certainly would be eye tracking studies on those topics out there. If you look for them and you have difficulty, please feel free to email me and I will look some up for you. Who is interested in doing an eye tracking study? Sophia could.
Well, actually, I wonder if Maria, if you would agree to review a master thesis on using eye tracking in education.
I don't know right now. If I think it's very interesting. Eye tracking is a very good tool. It is not. All methods come with advantages and disadvantages. Eye tracking could give us more information about certain things, but of course it doesn't answer all questions. My approach mostly to everything is to try it out and add to the knowledge we have. Eye tracking in education is very interesting. What topic are you studying?
She's focused on reading computer code and comparing that to reading math and natural texts in advanced and in naive programmers.
Oh, good. Sophia, you're in Perm, right?
Yeah.
Okay. So these are university students, right?
Yeah, this is a university student.
Mm-hmm. That's really cool. It sounds like an interesting topic, but I don't know. But if you look into the Institute of Education, there might be some colleagues there that might not have the eye tracking expertise, but they might have more pedagogical understanding of the aspects of how participants and strategists learn different things.
Thank you. I see.
So if I ask you a question, I can say, what if eye tracking is telling us what we're looking at, what does it not tell us? When we have a behavioral response, okay, when we have an output, so if I have a question and you give me an answer, I just have one single thing. I have the time you made a response, okay? And I have whether you did it correct or not. So that's a behavioral output, which was what we had for years and years. We had the answer, whether it is correct and how fast, maybe was the second thing we had. Eye tracking tells us where you were looking at when you were reaching the output, okay? But what it cannot tell us is what you were thinking, right? It is not a neuroimaging technique that has, let's say, bold activity in a specific area of the brain, and then we can say that you were thinking with this part, okay? We know that what you were looking at, so we know what you perceived, but we don't know what you cognized, what you thought. Okay, so this is a little gap. We can assume, and we can say if you were looking here, it might mean that you were thinking about this because you were looking at it. Okay, Alexander had a question. Maybe all our, of course, it is, it's really interesting to see that people have different interests, and you can examine all sorts of topics with eye tracking. There are a lot of studies with gaming industry. I have not looked specifically in those with chess, but there are some portable eye trackers. They're not as high resolution, but I know that in some places they're doing research where gamers are there, they are recording EEG and eye tracking at the same time, and they are playing very active games. Alexander, for chess and eye tracking, I would advise you to look again in the literature, just look up Google Scholars, say eye tracking and chess, and see what you get. And if you have any troubles finding things, please feel free to email me. I will put my email here. And what Any other questions? Okay, my last point, eye tracking is very exciting. The number of studies that we have in the last decade or so have exponentially increased. There's more and more studies, and with any method, I think it's useful to have more data than less data, but always be aware of the advantages and disadvantages because of each method, because eye tracking can tell us where eyes are moving, when they're doing so, and things like that, but it cannot tell us about the subsequent thinking that took place to give us the response that we have. And that would be complementary to techniques like neuroimaging techniques that can tell us more about which brain areas are activated when we're thinking, and then we can again speculate of what are the thinking processes that are happening there. Okay, thank you very much for joining me today. I will stick around for a couple of minutes if you have any questions. If not, I wish you a great evening. Thank you very much.